If I say radioactivity to you, you probably think I'm talking something along the lines of nuclear power stations or possibly making things glow in the dark. However, that's not all there is to it. And to understand a bit more about it, let's start thinking about an individual atom. Let's say an atom of carbon. How about this one here? So here we are looking at the carbon atom, and we can see the electrons around the outside and the nucleus in the middle. Looking at the nucleus, it seems to be wobbling backwards and forwards. Now, to find out why, we need to understand there are two things going on inside. The first thing is that all the neutrons and protons are being pulled together by a strong nuclear attraction. However, all the protons are being pushed apart by electrostatic repulsion. So you've got one set of forces pulling them together, one set of forces that's pushing the particles apart. Now this makes all the nuclei slightly wobbly, and if you get a really big nucleus, or one with the wrong mix of neutrons and protons, it becomes unstable, and that's what we call radioactive. Now, nuclei have got three possible ways that they can try and get more stable: alpha, beta, and gamma. Alpha is when it gives off particles which are 2 neutrons and 2 protons. These are relatively big particles and relatively heavy, and what they do is make the nucleus smaller and hopefully more stable. Another option, if there are too many neutrons, is to turn a neutron into a proton, and in the process a very fast and very tiny little electron is fired off from the nucleus. Another possibility for a nucleus that's got too much energy is it can fire off a burst of gamma radiation. This reduces the energy in the nucleus and makes it more stable. So, we've got massive alpha particles, tiny little beta particles, and a flash of energy called a gamma ray. Now, what can we do with all this radiation? Well, let's have a look. Now, what you see here is a very high-tech diagram of a carton of milk. Now, we can see little green dots in there that represent the bacteria that naturally occur. Normally there aren't too many, so when you drink fresh milk, there's no problem at all. Now the trouble is, we all leave the milk out. So what happens? The bugs start multiplying and multiplying until the milk is absolutely full of them. Now if we drink that, we'll be seriously ill. So, what they do in the dairy is they zap it with gamma rays. The gamma rays kill off all the bugs in the milk and make it safe for us to drink. Let's see that again. Zap. Those gamma rays did us really proud. Now, carbon dating is a very clever way that archaeologists can work out how old something is. When trees are growing, they're taking in carbon dioxide from the air. Carbon dioxide contains 2 different sorts of carbon, mostly carbon-12, but a little bit of the stuff in the air has got radioactive carbon-14 instead. Now eventually the tree dies and is turned into a piece of furniture of some sort. If we look at a piece of wood in this furniture and look very carefully, we will see that it still has both sorts of carbon, carbon-12 and carbon-14. Now remember, carbon-14 is slightly radioactive and will eventually decay. So if we watch the piece of wood over time, the carbon-14 is gradually decaying and becoming carbon-12. Now when an archaeologist digs up something that's made of wood, they look at the amount of carbon-14 and the amount of carbon-12. If an object has got a lot of carbon-14 still in it, then they know it was made of a tree that was very recently growing, therefore the object can't be very old. However, as the amount of carbon-14 decreases in the samples they're looking at, they know the objects must be older and older because the trees they were made from were growing longer and longer ago. And by using this method, archaeologists can quite accurately determine or guess how old a wooden object actually is. Now there's plenty more uses of radioactivity, from smoke alarms, body scanners, and even quality control in factories. So next time someone talks to you about radioactivity, don't start thinking, oh my god, it's going to turn me into a mutant. What you need to think about is the fantastic physics behind radioactivity. I hope you enjoyed this lesson.